Hello, so we'd like to look at number 5 from year 2010, Form B. Let's look at them together. So we have a differential equation in this way. And what they want us to do is sketch the slope field of the given differential equation and sketch a solution that passes through 0 through -1. So let's try to do this one first. We have 6 points here, 6 points here. And when y equals 0, obviously it's not defined in this way. So now when x equals -1, we notice that the numerator becomes 0. So when x equals 0, when x equals -1, we end up getting horizontal line segment. All right, now how about this is when x equals 0. Then when y equals 2, then we get 1/2. And then when y equals 1, we get 1. Y equals -1, we end up getting -1 slope and -1/2 slope. And how about 1, 2? Then slope is equal to 1. 1, 1, slope is equal to 2. And then 1, -1, x equals 1, but -1, so we end up getting -2. And then 1, -2 becomes -1. Alright, so something like this. Now, but on the other hand, we have 0, -1. 0, -1 is the 0, -1 is the value that we have. Now, then one thing that which we get to realize is that sketching the solution, this one seems to be going straight down this way. But to the left, it has to somehow curve down. As soon as it has the -1, slope has to be equal to 0. So we have going to the left, boom, something like this would have been our solution. Alright, now part B. While the slope field in part A is drawn only 12 points, it is defined at every point in the xy plane where y is not equal to 0. Describe all points where, so we have to see for what value of x and y the slope will be equal to -1. In order for us to see that part B, all we have to do is a slope. X plus 1 over y has to be equal to -1. Then one thing which we get to realize is -y will be equal to x plus 1. That means y will be equal to -x minus 1. So we get to see the relationship that for all values between x and -1, x and y, we get to have this relationship where slope will be equal to -1 then. Alright. Now part 3. Find the particular solution y equals f of x with this condition, initial condition. So let us try to look into this one together. So here we have dy over dx equals x plus 1 over y. Now then, what do we realize? First, we have to separate the variables. And by cross multiplication, we have y dy will be equal to x plus 1 dx. Then, once you take the integral from both sides, we end up getting y squared over 2 equals x squared over 2 plus x plus c. That's what we end up getting. Now, then what happens? Yes, we can multiply everything by 2. Then we have y squared is equal to x squared plus 2x plus c. Notice this c is not necessarily equal to this c because we multiply by 2. So we can call this one as a c1 while this one is c2. But for the convenience sake, we just call this c, the unknown. then y has to be equal to positive or negative, which we do not know yet. X squared plus 2x plus c. Now, knowing that when x equals 0, y has to be equal to negative 2, then expression has to be negative. So y has to be equal to negative x squared plus 2x plus c. Let's plug it in. Negative 2 equals negative c. Haha. Then c must be equal to positive 4 to have this one settled. That means our answer is y equals negative square root of x squared plus 2x plus 4. Alright. So with that, we've finished part C. That's it. See you later.